This is lesson 4 of unit 4. So we started with a ticket in the door today, so you'll need to make that up if you weren't in class. And then we did this warm-up, so you should pause the video, try the warm-up, and then check your answers. So the square root of 32 simplifies to root 16 times root 2, which is 4 root 2. And then I see a GCF between 2 and 4. So 2 times 1. Let me fix that. So 2 times, if I can get my pen to work here, 2 times 1 plus or minus 2 root 2. And that's all over 8, because 2 times 1 is 2, 2 times 2 root 2 is 4 root 2. So 2/8 simplifies to 1/4. So my final answer, 1 plus or minus 2 root 2 all over 4. Okay. So today in class, we learned how to go from standard form into vertex form. You know, the last few days we've gone the opposite way. We've gone from vertex form to standard form. So today we looked at a process called completing the square. So in your notes, go ahead and copy this equation, y equals x squared plus 4x plus 7. Now, to complete the square, to get this equation into vertex form, we used algebra tiles. So I have some algebra tiles here, and what we did at first was I just reminded students how to use them, because it's probably been several years, or maybe you've never seen algebra tiles. But this square here has dimensions x by x. Therefore, we call that the x squared square. You can see this rectangle here has the same height, x, but it has width 1. So the rectangles represent x. And these single squares, well, they have the same width as the rectangle, 1, and they have that same height. So they represent 1 unit. So if I want to represent this expression, x squared plus 4x plus 7, I'm going to use the algebra tiles to do it. So I need 1x squared. So I'm going to use 1x squared. And I told students, go ahead and draw that in your notes. We need 1x squared. I need 4 x's. So I'm actually going to take 2 of the x's, and I'm going to place them, I'm going to use the vertical ones, and I'm going to place them to the right of the x squared. Then I'm going to grab 2 more because I need 4 total x's, but I'm going to grab 2 of the horizontal ones, and I'm going to place them underneath the x squared square. So in your notes, draw yourself a diagram with 1x squared and 4 x's, but place the 2 of the x's to the right of the x squared square and 2 below. Now, I need 7 1 squares, so I'm going to go ahead and pull 7 of those. Oops. Okay. So now we have our expression here, x squared plus 4x plus 7. We have that represented with the tiles. So now that we have taken half of the x's and placed them to the right, and the other half and placed them below the x squared square, let's take a look at what we have. Remember, this process, this diagram we're building here is called completing the square. So what I'm going to do is I'm going to eventually have a square here. Okay. I currently don't have a complete square yet because I need to complete it. I need to complete the square. Oops. So, but what I do have so far, I do have almost a complete square. Okay. So I have, remember, this x squared square comes from height x. This is 1 and this is 1. So together, this entire side length is x plus 2. Same thing across the top. This is x, this is 1, and this is 1. So the entire length put together is x plus 2. So that's what I have so far. So I have an x by 2 by x by 2 square. Now, I still need to complete that square, though, so I need to take some of these 1 by 1 squares, and I need to fill them in to complete the square. So I'm going to do that. And I can see that it's going to take 4 of those 7 to complete the square. Okay. So I'll just keep those additional 3 out of the complete square. I have the complete square here, and I have 3 additional 1 by 1s. So if I want to rewrite this equation, which is currently in standard form, if I want to rewrite it in vertex form, well, what I have here is x plus 2 times x plus 2, or in other words, x plus 2 the quantity squared. And then I have an additional 3. Okay, so that is the vertex form of this standard form. Okay, now we visually completed the square. We did that using the tiles. We completed the square. But you're not going to have the tiles normally. You're going to algebraically complete the square. So now we're going to talk about what we would do, algebraically speaking, what we would write in order to complete the square. Okay, because I'm not going to draw the picture every time. So I'm going to start again with my equation, my original equation. So visually speaking, remember, we grouped the x squared square and the x rectangles. We grouped them together, and we kept the 7 1 by 1 squares off to the side. So algebraically speaking, we're going to do the same thing. We're going to put x squared plus 4x. We're going to group them together. I'm going to skip a little bit of space, and I'm going to end the parentheses. But that plus 7 I'm putting off to the side, just like I did in the visual representation. Next, we took 2 of the 4x's and we put them to the right of the x squared. We took the other half, the other 2, and we put them below. So mathematically speaking, if I don't have the picture to look at, I take the 4, which is the b value. Remember, ax squared plus bx plus c. I take the b value and I always divide by 2. I split it in half. You're always going to do that with completing the square, whether you have the picture or not. So 4 gets divided by 2, and that's 2. Now, we need to figure out what number here needs to go here in order to, back to the picture, complete the square. Well, we needed 4 tiles to complete the square. So the question is, well, what do I do with 2 to get 4? Well, I had 2 here and I had 2 here. So 2 squared gives me 4. So after we divide the b value by 2, we square that number. And 4 is what I add inside the parentheses. And me adding that 4 completes the square. Now I have this perfect square trinomial. Okay. So that's why I want to add the 4 to complete the square. But me doing that, completing the square, this step right here, I randomly added a 4. I had an x squared, I had a 4x, and I had a 7, all in the original problem. Well, when I completed the square, I randomly added this 4 on. And you can't ever take a problem, take an equation, and change it, which is what I did. I changed this equation by adding 4. So if I want to balance things, balance the equation by making it okay that I added the 4, I have two options. I could add 4 to the other side, over here to the y, or my other option is subtracting 4 on the end of the same side. So I added 4 on the right side, now I'm subtracting 4 on the right side of the equation. So that makes it like I never really did anything at all. Okay, so that makes it okay that I randomly added on the 4. Well, that helps me, though, adding that 4 and subtracting it, helps me because this right here, this trinomial, can be rewritten as a binomial squared. X squared plus 4x plus 4, if I factor it, it factors into x plus 2 times another x plus 2. So that's how I rewrite this trinomial as the binomial squared. The other way that you can figure out it's x plus 2, besides factoring this trinomial, the other way is you look at what number you got after you divided by 2, and whatever that is, this is a positive 2, I write that with x. So x plus 2, the quantity squared. Okay, and that's the number that you got when you divided by 2 before you squared. So x plus 2, the quantity squared. And then I just combine these two numbers, 7 plus negative 4. 7 minus 4 is positive 3. So that is how I got the equation into vertex form. Okay, so this step here, right here, that is us completing the square. All right, you have to show that. Here we didn't because we had the visual picture. But if you don't have a picture, the algebraic step of completing the square is right here. Okay, so I showed that, then I rewrote it in vertex form. The last part of the direction says state the vertex. We know plus 2 means left 2, so negative 2, and plus 3 means positive 3. So negative 2, 3 is the vertex. Okay, next one. So copy that. This is also by completing the square. No picture this time, no tiles. So we have y equals, we group the x squared and the 8x, skip a little space, and then minus 4 goes on the outside. So I take half of the b, so half of 8, and I square that. And that's what I add inside the parentheses. I randomly added 16 on the equation, so I have to make it okay by subtracting 16. Next, I'm going to take that trinomial and rewrite it as a binomial squared. So I can either factor the trinomial or come back over here and look at what I had when I divided by 2. So x, it's a positive 4, so plus 4, the quantity squared. Combining negative 4 and negative 16, that's negative 20. There's my equation in vertex form. The vertex, negative 4, negative 20. Next. So same idea, except for now we have a negative b. That's okay, the process is the same. So I'm going to take half of b, which is negative 3. I'm going to square that, which is positive 9. Positive 9 is what I'm randomly adding on. So to make it okay, I'm going to subtract it away. I rewrite the trinomial as a binomial squared, and that factored, or look back over here, we had a negative 3, so x minus 3, the quantity squared, and negative 9 plus 1 is negative 8, and that is vertex form. Vertex, right 3 and down 8 takes me to 3, negative 8. Next, process is going to be the same. We start off by grouping. We take half of the b value. Now, this doesn't divide so nicely. 5, when we divide 5 by 2, we're getting a decimal. Well, we're not going to state it as a decimal. We're going to leave it as 5 halves because I don't want you to use the calculator. You should be able to do these in your head. So if I have 5 and I divide by 2, I have 5 halves. So then I square 5 halves. The reason we're doing this without decimals and using fractions is because I can easily square 5 and 2 in my head, but it's harder for me to square 2.5, which is 5 halves. It's harder for me to square that in my head. So 5 halves squared is 25 fourths, because 5 squared is 25 and 2 squared is 4. So 25 fourths is what I'm adding on and taking away. So I have a binomial squared. Again, I'm looking over here. What I had before I squared was positive 5 halves. And then I need to combine negative 2 and negative 25 fourths. Well, I need to get negative 2 into fourths. So that's negative 8 fourths. Negative 8 fourths minus 25 fourths is negative 33 fourths. That is my equation in vertex form. You do not need to change these impropers into mixed numbers. You can if you want to, but you don't need to. Vertex, adding 5 halves is left 5 halves, so negative 5 halves, and down 33 fourths, so minus negative 33, or negative 33 fourths. Okay, next, this one. So maybe you want to pause the video, try it, and then play to check your answers. So I group, skip a little space, plus 4, take negative 3 and divide it by 2, square that to give me 9 fourths. 9 fourths is added and subtracted. Rewrite it as a binomial squared. X, come over here, minus 3 halves, the quantity squared. I need to get 4 into fourths, and I know that's 16 fourths. 16 fourths minus 9 fourths is positive 7 fourths. So that's my equation in vertex form. Vertex positive 3 halves and positive 7 fourths. Okay, next. So go ahead and copy that one. All right, so this time I go to group. And I'm about to start the process of completing the square, but I don't want to just divide 8 in half and then square that. And there's a reason why, and that's because the x squared is a 2x squared. And if you think back to the visual representation with the tiles, we had a 1x squared. We had one square here that we built the giant square around. Okay, so you cannot complete the square with more than one x squared. I need just one. So I can't just take this 8 and divide by 2, square that. Okay, can't complete the square unless it's a 1x squared. So whatever the a value is, in this case it's a 2, that number needs to be factored out. Okay, so because it's a 2, because a is 2, I'm going to factor out that a value. When I factor out a 2, I'm left with x squared, and I need to factor the 2 out of 8 as well, so plus 4x. Notice the positive 3, that constant, I did not factor a 2 out of that. That always just stays on the end till the very end of the problem. Now, I'm ready to complete the square because I now have a 1x squared. So I can take the 4, divide it in half, and square that. And 4 is added on to complete the square. Now, I'm ready to subtract on the end. And you have to be careful here. I am not going to be subtracting 4, which you may have thought, okay, because I added 4. Well, I actually didn't add 4. If you look closely, what I added, even though it says plus 4, it's actually plus 4 times the 2 that's in the front. So really what I randomly added to this problem to change it was a positive 8. That's what got added. So that means to make it okay that I randomly added on 8, I'm going to subtract 8. Okay, so when you have a coefficient, leading coefficient that's something besides a 1, you'll have to remember to multiply that number that completed the square by the a to figure out what it was that got added, and then subtract that number away. So now I have the 2 in the front. I have a quantity squared. And again, I figured that out the same way. I go back here to before I squared, which was plus 2. And then I still just combine the two numbers here on the end to get negative 5. That is vertex form, vertex negative 2, negative 5. We'll try one more today. So we'll start it the same way, grouping the 2x squared and the 12x, keeping the 13 out. I cannot complete the square because it's a 2x squared. So I'm going to factor out a 2. I'm left with 6x, 13 still hanging out on the end. Now I can complete the square, so I divide 6 in half, and I square that, and 9 is what is added to complete the square. Again, though, it wasn't really 9 that was added. It was actually 18, which means I have to subtract 18 to balance the equation. So I have y equals 2 is in the front, that's the a. X, I'm coming over here to see that that's plus 3, the quantity squared, and 13 minus 18 is negative 5. So there is vertex form, vertex negative 3, negative 5. Homework for tonight is pages 5 and 6 in your Unit 4 packet.